Hello there, and in this episode we're going to travel straight into the right direction and with a magnitude to look at vectors. And this is our second episode looking at vectors, so if you haven't listened to the first one, I recommend you do that before you listen to the rest of this episode. Now, vectors can be used to represent translations, and a translation can be written as a column vector where the top number is the number of units to the right, and the bottom number is the number of units up. Now I say to the right and up, but if they're negative numbers on the top or the bottom, that reverses. So the top number basically tells you if you're going right if it's positive, left if it's negative, and the bottom number up if it's positive, down if it's negative. So if we've got the translation, which would look something like some big brackets around a number on top of another number. So say we had 3 on the top, minus 1 on the bottom. That would move us 3 to the right and 1 down. Now, if we've got another one, let's say we've got minus 3, 4, you need to know that that moves you 3 units to the left because it's negative 3, and 4 units up because it's positive 4. Now, a scalar is also something you need to know about with vectors, and that is any number that goes before your vector. So when a vector is multiplied by a scalar, its direction doesn't change at all, but its size does. So a negative scalar will switch the direction of the vector, and that's the only situation that happens. Now, to multiply a column vector by a scalar, you multiply both the top and the bottom numbers by that scalar. So say we had 5, and then our vector was 3 on the top, 2 on the bottom. What you do is you 5 times 3 and 5 times 2 to give you the vector 15, 10. Now, to show 3 points, so we've got A, B, and C, to show that they lie on a line, what you can do is you can show that AB is a scalar multiple of BC. And that will basically tell you that because the scalar multiple doesn't change the direction at all, just changes the size. So if you're able to prove that you can times AB by something to give you BC, that tells you they're going in the same direction, and that tells you they're on a line together. Now, if given the side lengths in ratios, you can translate that into vector form. So say you've got vector A and vector B, and you know it's in the ratio 2 to 3 in terms of the sizes of those vectors. You can say basically that if vector A goes from A to B and vector B goes from B to C, then you can say that 2AB is equal to 3BC. And it's as simple as that. You just translate the ratios into a scalar for the vectors. So you need to remember that if you've got 3 points, let's call them X, Y, and Z this time, if they lie on a straight line, you need to be able to prove that X, Y is a scalar multiple of Y, Z. And that just means you can multiply those vectors by something to give the other one. So to go back a step, if we've got a vector 3 on the top, 6 on the bottom, how would that move something? How would that translate a shape? Well, remember, it's positive 3, so you're going 3 to the right on the top, and 6 up, because there's positive 6 on the bottom. And also another example for you, if you've got minus 3 on the top and 4 on the bottom, that will move 3 to the left, because it's minus 3, and 4 up, plus 4. And if a vector is multiplied by a scalar that is negative, that reverses the direction of the vector. Another example for you, if we've got 2, let's get the vector 2 minus 7, 2 on the top, minus 7 on the bottom, then we're going to move 2 to the right and 7 down. 7 down to minus 7, 2 to the right, positive 2. Another example, we've got 3, 6, 3 on the top, 6 on the bottom, that moves 3 to the right and 6 units up. And if that is all we're going to talk about looking at vectors in this episode. Join us again next time for some more maths topics for your GCSE Maths revision.